At the beginning of this section, we saw how to draw the graphs of the sine and cosine functions. We didn't quite complete the process. We were going to finish that in class, and we will do that. But you know how to do that now. You plug in an angle value, in this case for x, that's your input value, and the sine or the cosine spits out a new value, a half or 1 or the square root of 3 over 2, that kind of thing. And then you graph those points on an xy plane or a t f of t plane, and you get a function that looks something like this. The cosine graph's a little bit different. It starts here, goes down to -1, then comes back up again, but they have the same general shape. After that, we spent some time talking about some new vocabulary. We talked about the period of a graph, we talked about the amplitude, and we talked about how to find both of those things. After that, we learned how to take a graph of a function and determine its amplitude and its midline and its period and all of that kind of stuff, and use that information to write the equation of that graph. In this section, in this subsection, we're going to learn how to take an equation and figure out what its graph is. Now, there are many steps to this, and I apologize in advance. This video is probably going to end up being fairly long, but I'll do my best to keep it as short as possible. Let's write the equation of a sine function. I'm going to work with sine here just because you can do the exact same things with cosine, but I want to work with one or the other so there's not too much confusion. Remember that you can have an a sine of b times x minus c plus d, that's the form that these equations often come in. And also remember, and this is going to be especially important as we graph, that you want to factor out the b, leaving bx divided by b is x, and c divided by b is c divided by b. So these are two forms of the same function. They're very generic. Now let's take an actual function and use what we learned so far in this section to draw its graph. Here's our function. And we're going to need somewhere to graph it. Now the equation itself tells us this is a sine function, so we know we're going to be starting with the basic toolkit function that looks like this. I didn't write the instructions here. I should have included the fact that the instructions require us to graph at least one full cycle or one period. So we're going to be graphing at least one full cycle of this graph, of this equation, but we know it's a sine function, so we can start with the idea that the graph is that of a sine graph. And sine graphs go through 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, comma -1, and 2 pi. When you graph these, it's a good idea to leave a trace of the work that you do in your intermediate graphs. So in this case, I'm going to be using different colors to reflect the different stages that I go through. For this first one, I'm just using a light gray. You can use any color you like. I'm using something that kind of mimics the idea of a light pencil as opposed to a final graph, which might be drawn with a darker, heavier lead or heavier, or possibly even ink, black ink. It's worth pointing out that my graph looks a little bit different than the one here, and that's primarily because the scale is a little off. It's not off, it's just different. My 1 goes up about, well, a little more than there. If you were to measure this with a ruler, this would be a little bit longer than this, but my 2 pi is much, much longer than their 2 pi here. So my graph is a bit more spread out. That said, this is just the sine function, and I need this function, this whole thing here. So I have to make several adjustments to this graph to get to the equation of this graph. One of the first things we're going to have to do to get from this graph to the graph of this equation is to deal with the stuff that's inside the parentheses here. Now, I've mentioned this a number of times before, but I'll mention it again because it really is very important. In its current form, it looks like the horizontal shift is pi over 2, but it's not, because we haven't shifted the t by pi over 2, we've shifted 2t by pi over 2. So I'm going to rewrite this equation by factoring out the 2 inside the parentheses there. So let's rewrite this as y equals -4 times the sine of Now let's factor the 2 out of the argument here inside the parentheses, and then I still have -1. Now, when I say factor out, you have to remember that what I'm really doing is dividing 2t by 2, and that leaves a t. But then I'm also dividing pi over 2 by 2, and that leaves a pi over 4. So this is the new version of my equation. It's equivalent, right? These are the same equation. It's just that this one's been modified, and that modification is necessary to make sure we get our shifts correct. All right, so one thing we can do, the first thing we can do is take a look at where the variable is. In this case, it's t. And what is the thing inside the parentheses with the t? What is the thing most closely associated with the t? And that is pi over 4. So that's the first thing that I'm going to modify in my graph. Instead of having my graph start at 0, I'm going to have it start pi over 4 to the left of 0. And then notice that each of these 5 points that I graphed here are points associated with the parent function. If I take each one of those and plot it, pi over 4, or kind of one box width, if you see each of those major grid lines is a box, this distance is a box, right? Each one of these is pi over 4. So if I take each one of these and plot it pi over 4 to the left of where it was, I'll end up with points in these positions, and then I can connect those points. So what we have now is the graph of y equals the sine of t plus pi over 4. So that's the first adjustment we've made. The next one we're going to make is the next closest thing to the t, which is this 2. Now, this one's a little tricky. We've talked in the past about the formula p for period is equal to 2 pi over b. And that's our b right there. B is 2. So what b tells us is what the period is, but not directly. We have to work with this formula to figure out what the answer is for p. So I'm going to use this space down here to do that arithmetic, and then I'll erase probably most of that work just to give myself some more room. So given the formula p equals 2 pi over b, and given that I know what b is in this case, oftentimes I'll look at a graph and say, oh, I know the period. Let me put that in there and solve for b. But in this case, I have the equation. So I know b, I'm looking for the period so that I can graph it. So I'll replace b with what is in the position of b in my equation up there, my function right here, 2. And that means that p is pi. The period of my function is pi. So that means that instead of going from, I'll start with this one. Instead of going from 0 through one cycle to 2 pi, I have to do it in 1 pi. So I'm just going to end here, but I still have to get my full cycle in. Now, I could do that from 0 to pi, except that I've already shifted the graph to the left. So I need to shift my starting and ending points to the left as well. So let's use a different color here. Let's use, I think I'll use yellow for this one. And instead of going through the x-axis at pi over 4 and then again at 3 pi over 4, it's going to go through the x-axis at pi over 4 and halfway between negative pi over 4 and 3 pi over 4. And that halfway mark is, it looks like pi over 4. So in between those two, I'm going to hit my maximum. And then I'm just going to repeat the process on the in the negative direction to make sure that I have a nice, I wouldn't call it symmetrical, but mirrored graph. Now, I apologize, this yellow is kind of hard to see, but I wanted to use the yellow up, as it were, because later versions of the graph are going to be more important than this one. But this tells us we have the same shift to the left, but now we also have a compression as well. So this is the function y equals the sine of 2 times t plus pi over 4. And now I need to erase a little bit to give myself some room first to complete this version of the equation and also to continue. Now, the next thing I want to do is looking at the very first modification I made. Here's my original equation, and then I had to make a modification of the argument to be able to graph this piece of it. So the first modification I made was here. The next thing I want to do, the next thing that's the next closest thing to t, we've dealt with the pi over 4, we've dealt with the 2. The next thing the next closest thing to the t, to the sign of t, is the 4. And what I should be doing with that 4 is multiplying the values of all of the y values of my graph by 4. So 4 times 0 is 0, 4 times 1 is 4. The problem is I don't have a 4 in my graph. So I'm going to cheat. This is not something that you will normally do, but I don't have an infinitely large piece of graph paper here that I can work with and just shift it up. If I were doing this in the classroom or if I were doing it on paper, I would just add some more numbers or use a bigger piece of paper. So I'm going to change the 4 here to a 3. I'm just barely going to get away with this, but I'm going to change the 4 to a 3, and I'm going to do that here and here. And so there's that change. All right, so now I'm going to be looking at the function, and I'll use blue. Y equals the sine of 2 times t plus pi over 4, but I'm going to multiply everything by 3. All right, so I'm going to take my value of 1 and multiply. I'm going to take my value of 0, multiply that by 3 and get 0. My value of 1, I'm going to multiply by 3 and get 3. 0 times 3 is 0. Negative 1 times 3 is negative 3. And 0 times 3 is 0. Now this graph ends up looking something like this. Now we're getting much closer to our original function. The things that are missing are the minus 1 at the end, but also this negative. So I'm going to stick a negative in front of this. And I'll use that pink now to graph this function. The only change that I've made to the blue function and the blue graph that you see on the screen is to make the pink function, I have to flip it over. I have to make all the positive values negative and all the negative values positive. So I'm literally going to take this value and drop it to negative 3. And this value and push it up to positive 3. All right? And so I get this function. Now the last thing in our function is this minus 1 at the end. And just like all the other transformations of functions we've dealt with, this is take whatever you've got, which is what we have here. Take whatever you've got for your function and reduce it by 1. Take 1 off every y value. And the effect that that has on the graph is to drop it by 1 unit. So we're going to shift the graph down by 1 unit. I'm going to use a white ink for the equation. I now have negative 3 times the sine of 2 times t plus pi over 4, and I'm going to take 1 off all the y values. But because I'm drawing on a white background, I'm going to use black for my final graph. So taking all of where I currently am is the pink graph. I have these critical points that I've graphed. Basically, I've graphed these 5 points for every one of the graphs that I've done so far and just connected the dots. And those points have been the things that I've shifted around and then I've connected them. And so for the last graph, I'm going to take those values and subtract 1 from them. This is what I meant when I said I was barely going to get away with this. So now I'm not multiplying by 1 or multiplying by 3, so I'm not going to end up here. I have to come down 1 for every single one of these points. And so my last graph looks something like this. I'm using a thicker pen as well. That's intentional to try to make it really stand out. And I'm not going to claim that that's my best work. It's a little squiggly through here. It probably doesn't have quite the right curvature here. But I've made all the important features really clear through each step of the process here. So if I were turning this in for a grade, I would say maybe final graph. You can either use the same color or you can point to it. You could use, instead of using different colors like this, if you don't have access to different colors, you could do your final graph in black, but maybe you use a much lighter pencil for your previous graphs. Maybe you use thinner lines. There are lots of different ways to do this. Dotted lines, maybe. So for your intermediate graphs, use a lighter shade, use a dotted line. Make it really clear where your intermediate graphs are and where your final graph is. My ultimate solution here is clearly labeled, the final graph. The work that I've done in between is clearly labeled, and I've actually even included the equation of the graph, like the yellow equation here, looks incomplete because it doesn't have the -3 in front, doesn't have the -1 or -1 at the end. But in fact, my yellow graph is the graph of this equation. So this is not necessarily necessary. It's not technically necessary to include this information, but I will tell you that if this information is included, it will be much, much easier for me to troubleshoot any problems that you're having. So I highly encourage you to try to do this. Tell me what each one of your different colors represents and how you're changing your toolkit function, which in this case is the gray graph here. And I don't have that here. I could add it. Let me just do that quickly. Y equals the sine of t. All right, so now each one of my graphs has a matching equation, and it matches in color. If you don't have colors to use to do this, you could say, well, this is equation 1, this is equation 2, this is equation 3, and then you can say this is 1, and this is 2, and 3 was yellow, so I'll go in here and say this is 3. That's another way to label them. Okay, just give me as much information as you can because it will help me troubleshoot it if there are any issues. And it will also help convince me that you understand the process. Just graphing the final graph will not be enough. Because if you're doing this at home, you could just graph it on Desmos and find out what some points are and click on those points and plot those and connect the dots. And that's not what I want. I want to know that you understand what it is we're doing with these things, what each piece represents. So you might be asked to do one of these on a basic skills test. You might be asked to do one of these on a challenge set. I want to see your actual steps. I want to see the interim steps in the process, not just the final product. Okay, that's lecture over for this subsection. The next section is called Using Transformations of Sine and Cosine Function, and I haven't read it yet, so I don't really know what's going to be involved in that. I'm going to hope to make that video as short as I possibly can.